This jam question says, in how many ways can a delegation of 3 be chosen from 5 men and 3 women if at least 1 man and 1 woman must be included? The delegation of 3, they are 8 in number, but the delegation is not randomly done. You must choose at least 1 man and 1 woman. So how do we do it? If you choose 1 man, if you decide to choose only 1 man, then the remaining 2, because you need 3 persons, the remaining 2 will be women. And if you decide to choose 1 woman, the remaining 2 will be men. But you cannot have 3 men and no woman, or 3 women and no man. So you must have at least 1 man and 1 woman. So the possibilities we have are, out of the 5 men, if you decide to pick only 1, then that is, and out of the 3 women, you have to pick 2 in order to make them 3. Or if you decide to pick 2 men, then you will have 1 woman to make them 3. But you cannot decide to choose 3 men because you need only 3 persons. So if you choose 3 men, there will be no woman. But the condition is that there must be at least a woman. So this is how we are going to do that. And then if we simplify this, we're going to have 5 combination 1 is 5 factorial over 5 minus 1 factorial into 1 factorial, which of course we know that any number combination 1 is still that number. But I just want to show us how it is done. We have 3 factorial over 3 minus 1, 3 minus 2 factorial into 2 factorial, okay, plus 5 combination 2 is 5 factorial over 5 minus 2 factorial into 2 factorial, then times 3 factorial, 3 combination 1 is 3 factorial over 3 minus 1 factorial into 1 factorial. And I said any number, because 5 minus 1 is 4 factorial, and 5 times 4 factorial, 4 will cancel 4. So any number combination 1 is still that number. So we have 5 here, times 3 minus 2 is 1 factorial, this is 2 factorial, 3 times 2 factorial, 2 factorial here will cancel 2 factorial here, and we are left with also 3. Any number combination, the number before it is still that number. That is 9 combination 8 is 9, 10 combination 9 is 10, in that order. So we now have plus again, 5 combination 2 will give us 5 times 4 times 3 factorial all over 5 minus 2 is 3 factorial, then times 2 times 1, 3 factorial will cancel 3 factorial, and 2 here will give this 4, 2. So we have 10 times any number combination 1 is still that number. So 3 combination 1, which is 3 factorial over 3 minus 1 factorial, which is 2 factorial, will give us 3. So we are going to have 5 times 3 is 15, plus 5 times 2 here is 10, times 3 is 30. 15 plus 30, 15 plus 30 will give us 45 ways. So there are 45 ways of selecting 3 persons from 5 men and 3 women, such that at least 1 man and 1 woman must be included. See you in our next class.